In this video tutorial, I'm going to show how to check out the PySpace software, where to check it out from, and I'm going to give an example of how to check it into an IDE. In this case, I'm going to use the Eclipse IDE. The project is based on Eclipse, but it doesn't have to be developed with that tool, but this is just the example of how it works. So the location of the software is on Sourceforge. It's called the PySpace Physics Software Project. It's your standard Sourceforge project. I have a file section where one can download the latest snapshot, which is a jar, and there's some readmes and a tutorial, a software tutorial, and there's a zip file with the source code. And there's a simple document on a business case for the theory. There's also a wiki where I talk about the various things you can do with the theory, and there's also the code and how to get the code. So you might be inclined to just check out the code. So the way to do that is you go in here and you just copy this here, and then just switch into Eclipse and to do file import project from Git, clone, and you put the URL or the URI in here, and then it breaks out the various bits here, and you just do next, and it'll pick it up, and you just check it out as a project. You'll import that project into your IDE read only. Now to save on time, I've already done that, and the code base is not too large. It's mostly the formulas that are established in the theory, and the example I've been describing has been the trajectory, the how to calculate a trajectory. The trajectory formula method is in here, and if you want to test it, there's or any of the formulas, there's a JUnit test harness here, and it's called the PySpace test the PySpace trajectory. The example that we can take a look at is just going up and down. This one here. So just going up and then down. This one here. So I'll click on that one. So this is the test program to just test going up and then down. So you create the formulas object, and then you pass in the mass, the number of the seconds or fraction of a second you want each iteration to go over for the trajectory. You have the mass of the planet, the radius, how far you are from the radius, and you then create the trajectory info object. This basically this represents the information in the diagram I showed in the previous lecture. So you've got the angle with respect to gravity, and then you have the distance from center of gravity, and you've your starting positions, in this case 0, 0, the velocity, the angle that you're throwing the object or moving it, which is straight up, the stepwise time, which is in milliseconds, so it's 1,000, 1 second, the radius of the Earth, the mass, and the mass of the object, and then the mass of the Earth, and then if you want to use the PySpace formulas or not. Then you have this criteria, which is to do with the velocity, which is a velocity criteria, and then you run the algorithm for 5 steps. You can run it as many times as you want, but in this case we just want to run it 5 times. So just see it going back up and then back down again. Then to run it, all you need to do is just do run JUnit test. Down here, the console shows the output. Now, because it's a test harness, there's a lot of debugging information, but the core idea is that each step is highlighted. So there's 5 steps, and you just follow each step. step 2, and then in step 2 we can see that it's slowing down as it's going up, and then it's slowing down again. Should slow down again, slows down again. Okay, and then it speeds up. It speeds up going in a negative velocity. So it goes up and then comes back down again. And that's it. So if you want to explore the code, just check it out like I've shown you, and just run the test harness, and that's all that should be. It should be pretty straightforward. Just use Eclipse, and just you can clone the Git repository, and it's read only. That's it. Have fun.